Alright, in this session we will talk about the robotic toolbox and machine vision toolbox. If you go through your textbook, actually your textbook follow a really clear way to explain the theory behind the toolbox and mathematical or linear algebraic equations and the operations based on your toolbox in parallel to your theory. That's why Dr. Jamshidi was talking about, yes, you see just rotation and translation matrices, but those matrices just for one link. If you have 6 link, which is the industrial manipulators, they have 6 degree of freedom. You have one matrix, each element has 3 by 3 matrices inside. So that's why the toolbox is based on representing the kinematics and dynamics of serial link manipulators. You're basically skipping all those mathematical representations and do the operations by yourself. The parameters are well defined, and for some manipulators, the parameters, the coefficients are pre-installed, provided with examples, which is Puma 560, for example, right? These parameters are encapsulated in MATLAB objects. They are objects. And robot objects can be created by the user for any serial link manipulator, which means you can play with those parameters. You can change those parameters, and you can change your robot's position in 3D space, and you can change your work environment, play with those parameters, and create your own manipulator, which give you later the forward kinematic, right? Okay. Robotic vision and control textbook. You just need to click here, and here you are. This is web-based textbook of this class. You just here chapters, for example, for mobile robots. MATLAB code examples, all figures. Oh, sorry, my bad. Maybe it's extended, yeah. So, yeah. Yeah, even MATLAB codes and examples, all figures are here. A brief summary. Robotic toolbox. Alright. What about robotic toolbox? Okay, sorry, let me go this way. And please do not afraid to read things. Don't just look for numbers, equations, and simulations. Please read this, okay? The web page. It's a good introduction. And here, downloading the toolbox, download it from here. Could be a zip file. You already downloaded, right? Did you? Yeah. Once you download, it will be a zip file, .zip. Then you unzip it and put on your workspace, which is actually you're adding to your path here. 9.9, 9.10, and vision. Okay? 9.9. Once you basically you can follow this. Okay? Copy, paste in your browser, or if you use Windows Explorer, copy and paste this address and put your robotic toolbox there. It will be in your workspace. Otherwise, you have to click on here, right click, add to path. Select folders? No, select folders and subfolders. Okay? Now, it's not transparent, it's not in hollow, right? The same thing for the Vision Toolbox. Select folders and subfolders. Be good. Once you are there, you can do this. Execute the startup file. Basically copy and paste this command to your command window and execute. Enter. If there is a mistake, an error with if it's not compatible with your Vision, or there is a mistake on your toolbox, you will get an error. Just delete the zip file, download again, or put your MATLAB folder. And run the RTB demo, the short demonstration. And also documentation, which is important. See robot.pdf. A handbook for the toolbox. See? Functions by category. 3D transforms, 2D transforms, homogeneous points and lines, differential motion, trajectory planning, dynamics, mobile robots, for example, map, random paths, make map functions, localization. And here also we have animations, which is cool thing with this toolbox. And same thing for the machine vision toolbox. Those are different toolboxes. Please read and download the Vision, Simulink and Common folders. All the Simulink models inside that toolbox is actually, they have their own folders. Once you click, you can see all the Simulink models. You don't have to go online. And here, the handbook. And also, for the robotic toolbox, he is also explaining what is different than 9.9 and 9.10. And all this, the functions and objects. Alright. For example, here, that's the cool thing with the robotic toolbox. Everything is clear. All the functions actually self-explanatory. Why? What are you seeing here? Ang, vec, 2r. So, angle, vector, to rotation. Angle, vector, to rotation. Angle, vector, to transform. Then, of course, the parameters you have to put in between the parentheses. For example, let's try to do some demonstration. If you have your laptop and MATLAB with you, you can follow as well. For example, I already had my Toolbox 9.9 and Vision Toolbox, right? Let's add 9.10 as well. Alright, here I'm simply taking this here and execute. Oh, wait, sorry. Yeah, alright. Here is it, my translation methods. These are the parameters in two link, rotate by pi over 180, which is 1, and 30 degrees, right? 30 degrees, pi over 180. Then I want to work on, or I want to see my workstation, work environment. This is my work environment. So here you go. X is 0, 5, 0, 5. X starts from 0 to 5. Same for Y. 0, 5, 0, 5. Okay? And if I want to see this, I can say grid on, I guess. Right? Okay. Then I want to see my first robot in its workstation. So X, Y, and Z is towards it. Then let's put another one. This is the second one. And let's plot this one. And if you use up arrow, you can go to the last command, right? And let's make this red and show as 2 in the frame and my T2 object. Okay, where's my figure? Here you go. And also, if I say, you see my T1 is disappeared. If I say hold on, it will hold the plot and show whatever I'm plotting. Here is my T1 is here. And then same for T3. Oh yeah, T3 equals to T1 times T2. Right? Then let's make this green. Name it as a third one and T3. Here's my wait. So let's plot them again. Alright. Here's my T1. Say hold on. And T2. Here's T2. And T3. Oh,
don't you need to do another one?
no, I don't think so. Let's try. Hold on. No, I don't think so. Yeah, maybe I need to just take off this. Alright, let's do it again. T1. Yeah, see? I got just, the MATLAB just throw an error. So I need to remove Toolbox 9.9, okay? And keep 9.10. And now just give it again. T1 equals to this. Wait. What am I missing? Yeah. Alright, T1 and T2. First create my workstation here. And T2. I plot it. And hold on. T2. Alright. And T3 is T1 times T2 and T3. Yeah. Alright? I forgot to put x is 0, 5 for each x and y's. Okay. Now see, 1 is here, 2 is here, and T3 is T1 by T2, but it totally in a different location. Let's say T4, for example here, T4, let's create another one, T4 equals to T2 times T1, okay? And plot T4 as different color, name it F4 and T4. Alright. Here's 4. And let me make it green. Alright, see? There is 4. If it's hard to see, can you see it? Okay. So, don't expect if you have two different verb environment. Those are actually your coordinates, right? Your central coordinates. Your robots is just here. And you make some transformations, and the T3, the third environment is not actually as expected between 1 and 2. Okay. Let's do another. And for cleaning your, you see every time I'm working, the MATLAB just creates elements here and shows its values, which is in this case the matrices. To clear this, you just need to say CLC clear all. CLC will clear your comment window. If you say clear all, okay, before that let's say T1. Here's my T1. Okay? T2. These are all my workspace. So if I say clear all, MATLAB will clear all the elements in workspace, and I have nothing here. Let's say T1. There is no T1. It just wiped memory. Okay. Another example for rotation. Here is my rotation based on, see, R equals to rotation x coordinate p over 2. The amount is, if, like, let's say z, y, x. On x coordinate, rotate my coordinate system 90 degrees. So it's turning like this, or let's say minus up here. Okay, let's see that. TR plot R, capital R. Here we go. X, Y, and Z coordinates. Then the animate, right? TR animate R. And I'm going to keep the plot here. See? My coordinates just changed. Let's take another example, which is actually we are rotating our coordinate system with respect to x by pi over 2, with respect to y by pi over 2. So we're turning x and y coordinates by pi over 2, 90 degrees. Same thing. Let's see the plot. The new plot is here. Remember the previous one? The x was, let me show. The x was here x, right? The previous it was here, and y was there. Alright. let's see how it's changed. We have a function, right? Animate R. Here we go. 90 degrees by Y. So we turn first. Let's see. Let's talk about this. First, we change the coordinate system 90 degrees with respect to X. So X stays the same, and Y and Z changes, right? Turns. Then, based on that, the final will be with respect to Y, 90 degrees. Okay, watch. X here, Y here, X comes here because of Y, and Z and Y comes here because of X. Okay, be clear. Alright, another example. And if I use semicolon, I will not see my output on my workspace, right? In MATLAB. If you don't, you will see it. For example, alright, this. Okay. Here, I have this. See, if I use semicolon, I will not see the R output. Alright. Now I change my coordinate system again, rotate them, and I want to see how, based on vectorial and the angle. Here's my theta change, it's reading, right? 0.38, and my new vector, the coordinate vector is on 0.3, 0.4, and 0.8. Remember Dr. Jamshidi was talking about the matrices based on transformation matrix, a rotation matrix. For each X, Y, and Z, you have 3 different rotation matrices. They multiply with translation matrices. So you can find your final destination in the 3D coordinates based on your foundation, your home position, right? Home position is like this, for example, for Puma. Then you make some translation and rotations. So this is your end effector, your final destination. How can you find it? You have to calculate, multiply those matrices with each other, right? So this is the easy way. See? 0, 0, 0, 1. And he was saying the last element is always 1. Remember? So you have to take a look at your textbook, I guess, because it seems you need. Okay. If you have your laptop with you, just open your PDF file for textbook. Here we go. Then I'm just saying TR2 or T, translation to rotation. Okay? Change it? No. Let's try. Oh, I don't have my And you can find this from the lecture slides. Okay. You see, now we just trying to do, let me put the equation on the screen and let me draw the tooling manipulator for you. Remember we were doing the translation and rotation, simply TR to R and trans to inside the parameters between the parentheses. Now we have simple tooling manipulator. Let me draw it for you. These are joints, right? This is the joint, let's say joint N plus 1 and N plus 2. Joint. And I have a little rotation here, a little bit here, a little bit here. And let's say here I have this. This is my coordinate. Z N Y N. Oh, let me say it like this. Z Y and X. Okay, and here I have Z N minus 1, Z N plus 1. Okay, and here I have, if I take a look at here, then go here, and here, I have, my parameters are coming, right? Dn plus 1. A n plus 1, and here's a little angle alpha, right? And my theta is here. I'm trying to draw the parallel lines, okay? So this thing parallel to this line. So my theta is here. And based on here, the alpha should be somewhere between this angle, right? Here is alpha. And this is link n. N plus 1. Now, actually let me take a break here. All right. Then we'll talk about it later in the next session.